this case, the area is going to be different to the first integral. It's going to be integral from alpha to beta. So let's say this point, at this point, the parameter alpha t equal to alpha. And at the second point, the parameter t is equal to beta. Okay, so this doesn't mean, the point is named beta or alpha. It means at this point, the parameter t is equal to alpha. So we integrate from alpha to beta. And so we have here g of t times the derivative of f with respect to t and dt. So you guys can see it is similar to the first question. It's the first formula. It's exactly the same thing. But we have to add one more thing here, because when you calculate this integral, you will get a negative number. The second integral, the blue one, gonna returns you a negative number. The reason is your curve is below the x-axis. And as I told you before, when your curve is below the x-axis, the integral gonna returns you a negative number because your function is negative. So that's why I said, at this time, what you have to do is to add a negative sign in order to make it positive. Don't forget it here. It's going to be minus integral from alpha to beta. Okay. And we have minus here. So basically it means when your function is, your curve is above the x-axis, to calculate the area, so you guys have to use this formula, the first one. And when the function is below, you apply the same formula, but you have to multiply it by -1 in order to make it positive. Is okay? So next we're going to do an example and we'll see how to apply, this formula. So in this example, the graph is given. So this is my curve C. This is my curve C. And we would like to calculate the following area. So we want to calculate this area between the curve and the x-axis. And here is, the function f is right here. And this is the function g. But we don't know alpha and beta, so we don't know here alpha. The value of alpha is not given. Same for beta. So that's why before calculating the area, so we need to know these two values, okay? And be careful, the values are not equal to the point where the curve crosses the x-axis. No, these points are, where t is equal to alpha. Okay, so the first point here is when t equal to alpha, and the second point is when t equal to beta. And these 2 points correspond to the x-intercept. So it means where the curve crosses the x-axis. That's what we mean by x-intercept. And as you can see from the graph, any point belonging to the x-axis has its y-coordinate equal to 0. We're going to start by finding these 2 points first, and then we can apply the formula. Okay? So we need to find, the values of alpha and beta first before I'm solving this. All right, so as I mentioned here, we're gonna find, the values of alpha and beta. And you guys know the values of alpha and beta correspond to the x-intercept. So that's why we need to find the values of t corresponding to y equal to 0, because any point belonging to the x-axis has its y coordinate equal to 0. And setting y equal to 0, we substitute y by its equation and we solve for t. And doing so, we'll get two solutions, t equal to 0 and t equal to 6. So it means when t equal to 0, the curve crosses the x-axis. And when t equal to 6, it crosses also the x-axis. And we got our two x-intercept. So now from the graph, you guys can see the graph is below the x-axis, as I told you. It means when you apply the formula that we've seen before, we have this situation. We have the second situation here. The curve is below. That's why we have to add a negative sign in front of the integral. Okay? So doing so, we'll get here minus integral. As I told you, the reason is, what I explained before, the curve is below. And we integrate from 0 to 6. And we have f of t, which is the equation of y, times the derivative of g. Is g of t, sorry, in derivative of f, which is, which is x. So I'm going to substitute y by its value because this is my g. And we replace here x by its equation. But don't forget, here we have to differentiate it. That's exactly what the formula says. Now, when you differentiate the second bracket, you guys will get t, and you put it inside to expand, the integrand here before calculating the antiderivative. So when expanded, you will get t cubed minus 6t squared. And don't forget, we already have, the negative sign at the front of the integral. Now, when we calculate the antiderivative by using the power rule, you guys will get here 2 to the power 4 by 4 minus 2t cubed. And this is the antiderivative. You have to calculate it at 6 and at 0. Taking into account, the negative sign here in front of the bracket. So when t equal to 6, you guys will get the first bracket here. And when t equal to 0, it's going to be 0. When you calculate this bracket, you will get negative 108. And with this negative sign, it becomes a plus 108 squared. Any question? No. You have to solve y equal to 0 because you want to find the x-intercept. If you solve x equal to 0, you will find y-intercept. Okay? And you only have one y-intercept, as you can see from the graph here. You only have one y-intercept is this point and two x-intercept. Okay? Why do you have to solve y equal to 0? Because any point belonging to the x-axis, we're looking for x-intercept. So the x-intercept is always a point on the x-axis. And any point on the x-axis has its y coordinate equal to 0, as you can see here. All these points on the x-axis have their y coordinate equal to 0. That's why we have to solve y equal to 0 in order to find the corresponding values of theta here for these 2 points. Okay?
Could you please zoom out a bit?
Is it okay? Are you done? Okay, I repeat again, the reason why we have negative sign in front of the integral at the beginning, because the curve of C is below the x-axis. And I told you, anytime you guys have the curve below the x-axis, the integral gonna returns you a negative number. And the area cannot be negative, so we have to make it positive by multiplying by -1.
So in the chat, is it show the graph or we also draw the graph by myself?
Pardon?
My question is the graph. Do we need to draw the graph, or the question had?
Now the question gonna provide the graph.
Okay, okay, okay.
Okay. And another way to show to see if your y is negative here, because x, if you want to know your y negative, you pick any number between 0 and 6 and you plug it here. Okay, so for example, you pick 1 between 0. If you substitute here by 1, you will get 1 minus 6 going to minus 5. It means it's a negative. That's why you have to add negative sign. Even if the graph is not given, you can do so. You pick any number between 0 and 6 and you substitute in the equation of y. If it's negative, so it means the curve is below, and then you have to add the negative sign. If it's positive, so you don't add the negative sign. And if the graph is given now, you don't need to do it. So you have just, look at if your graph is below or not. Are you done? All right, thank you. So next situation, now we want to find the area of the region bounded by a pyramid curve and the y-axis. This formula that we've seen was for the x-axis. So be careful. The formula are a little bit similar, but not the same. In the first one, it was g of t times f dash. So here we switch. It's going to be f of t times g dash, because here we're calculating the area between the curve and the y-axis. Okay, so we have something like that. All right, so in this case, we have something like that. Change the color. So let's say this, oops. All right, so we have the x-axis, for example, here, and we have the y-axis. And our curve, we just want to calculate the area of the region bounded by the curve and the y-axis. So let's say this is our curve. So we have one y-intercept here and another y-intercept. Okay, and so we want to calculate. So for example, this y, the first y-intercept coincide when t equal to alpha, and coincide the value of t equal to beta for the second one. Okay, And what we want to calculate is the area between this curve and the y-axis. So that's why we have to modify the formula in this case. So what we want to calculate is this area. But for this area, you guys can see no matter what is x, y is always, so the x is always positive here. Okay, you guys can see any point belonging to this area has its x positive. So it means in this case you want to calculate the area. So you guys have to use exactly this formula. Okay, so this does not mean the curve is below. This is not the way, because you calculate here this area. But if, for example, we change the situation, let's say the area is on the other side of the. So for this situation here, let's say we have this. So we have the same thing, but this point coincide with the value of t equal to alpha. And so we have here t equal to beta. Another y-intercept. And so our curve look like this. For example, again, we want to calculate this area. We want to calculate this area. As you can see, in this case, the area is on the left of y, and on the left of y, x is negative. So it means in this case, if you integrate, if you apply this formula, you will get a negative number. That's why you have to add a negative sign. For this one, the area equal to minus integral from alpha to beta. And so we have f of t times the g dash and dt. It's similar to the first formula, except here we add a negative sign. And I repeat again, the reason is when your area is on the left of the y-axis, and you want to calculate the area between the y-axis and the curve, so the integral gonna give you a negative number. That's why I have to add a negative sign here in order to make it positive. And without the negative sign, it's similar to the same formula here that we guys have. So next I'm gonna do some one example when we're gonna apply here. Just keep in mind, when the curve is below the x-axis and you calculate the area between the curve and the x-axis, you have to add a negative sign. Otherwise, so you calculate the integral directly to get the area. If your function now, you calculate the area between the curve and the y-axis, so you have to check if the area is on the right of the or on the left. On the right, you apply the formula, or the left, you add a negative sign. All right, so here again, we want to calculate this area. As you can see, we want to calculate this area between the curve and the y-axis. It means you have to apply the previous one of the previous, formulas. So since the area is on the right of the y-axis, it means you apply the formula without adding a negative sign, because it's already positive. The integral gonna return you a positive number. So what you have to do first is to find this point here, the values of t corresponding to these 2 points, the y-intercept. That's what you want. we need to get here t equal to beta. So we need to find beta here. And here t equal to alpha. So basically it means we have to find the values of alpha and beta corresponding to the y-intercept. And as you can see, any point belonging to the y-intercept has its x-coordinate equal to 0. All these points belonging to the y-axis have their coordinate, the x-coordinate equal to 0. So that's why if you want to find the x-intercept, the y-intercept, we have to solve the equation x equal to 0. Okay, in the first question, we was looking for x-intercept. That's why we solve y equal to 0. Now we're looking for y-intercept. That's why we have to solve x equal to 0. All right, so as I said, oops, let's see. All right, so we have x equal to negative t squared plus 8t, and y is equal to t squared. And the y-intercept are the point belonging to the curve and to the y-axis. And as you know, any point belonging to the y-axis has its x-coordinate equal to 0. That's why we solve x equal to 0. And when you guys solve x equal to 0, so we'll get here, the common factor is t equal to 0, or this bracket equal to 0. This involves t equal to 8. So it means alpha equal to 0 and beta is equal to 8. Now we have to integrate from 0 to 8. And the formula says it's going to be the equation of x times the derivative of y with respect to t. And when we substitute x and y by their values, we'll get, these two brackets. And the second one is y, and we have to differentiate it before calculating the integral. So when you differentiate this bracket, you guys get 2t, and you expand it. Okay. Now when we expand it, we'll get here t, 2t times negative t squared going to be negative 2t cubed, and 2t times 8t going to be 16t squared. And now we're ready to apply the power rule for integrals or for antiderivatives. So when we apply, we get negative t to the power 4 by 2 plus 16t cubed by 3. So at 8, we'll get the first bracket here. At 0, the bracket is equal to 0. That's why I didn't write it. So when you substitute t by 0, the whole bracket is going to be 0. And when we calculate this part, we'll get just 4096 by 6 units squared. So if you want, we can simplify here the solution by 2. Any question?
No, sir.
All right, I'll let you write down. And whenever you're done, you guys let me know. Are you done?
Yes, sir.
Okay.
Not yet, sir.
Pardon?
1 second, not done.
Okay. All right, so next we'll see how to calculate the area bounded by a polar curve. So here, you guys have this red curve, which is a polar curve defined by this equation, r equal to f of theta. So here is the equation of my polar curve. And this angle here is theta 1, and the big angle is theta 2. So the area that we want to calculate is this area below the curve of C, and when theta is between theta 1 and theta 2. So this is the area that we want to calculate. Okay, and calculating this area going to be equal to integral from theta 1 to theta 2, because theta is going from theta 1 to theta 2, and we have 1 over 2 the square of f theta is the f of theta is the equation of the polar curve, and you guys have to square it and you integrate with respect to theta. Okay. So anytime you guys have a polar curve and the values of the range for theta, and I want to calculate, you know, the area bounded by the curve when theta is in the range, which is theta 1, theta 2. So you guys have to use this formula. And that's exactly what is given here by this result term 4(3). That's what I showed you before. Now, if you guys have two curves and want to get the area between the two curves, we can generalize, you know, this formula, and that's exactly what is given by the second theorem, number 4. I'm just going to draw the graph here, and guys can visualize exactly what I'm saying. All right, so let's suppose here so here we have theta equal to 0. Of the pole. And we want to get the area between the two curves, f of theta and g of theta, by assuming, you know, g of theta is less than f of theta. So it means the curve of g going to be below the curve of f. Okay, so let's suppose here this is my, oops. All right, so let's suppose this is the curve of f. Okay, so this is f of theta. I'm gonna do g of theta, which is another function below. And this is g of theta. So you guys can see this condition here. G of theta is below is less than f of theta. That's why the curve of g is below. So it's going to be the grid function on the top. And we have two polar curves. Okay. Now I just want to calculate the area between these two curves when theta is between theta 1 and theta 2. So for example, let's say this angle here. So this is theta 2. And we have another angle which is equal to theta 1. I'm just going to take a black color here. And we have this angle. This is theta 1. Okay, so theta 2 is greater than theta 1. And we want to calculate this area below between the two curves. Okay, between the two curves when theta is between theta 1 and theta 2. This is what we're going to calculate. So when you guys want to calculate such area, so we can take the area below the red curve minus the area below the blue curve. And you guys will get the area between the two curves. And this is exactly what we did here. When you open this bracket, this is the area below the red curve minus the area below the grid, the blue one, and then you will get the area between the two curves. Okay, so basically it means when you guys want to calculate the area between two polar curves, is gonna be 1/2 bracket the square of the greater function minus the square of the smallest function. Okay, so next I'm going to give you two examples where we're going to apply these two formulas. You okay? Can I move to the next slide? All right, thank you. All right, so for the first example here, we only have one curve, and the range for theta is -π/4, π/4. So we just want to calculate, the area below the curve of R when theta is in this range between -π/4 and π/4. It means -π/4 gonna be theta 1 and π/4 gonna be my theta 2. So I have to integrate now from -π/4 to π/4. Okay, and we apply exactly what the formula says. So that's exactly what I did here. So we integrate from -π/4 to π/4, 1/2 f of theta. So this is my function, the polar curve, and it's given by this equation. You substitute, by its equation, and you square it. And when I drop the square brackets, so it's going to be just cosine square 2 theta. And the antiderivative in this case is going to be complicated because of the exponent. If the exponent wasn't here, so it's going to be quite easy to get, the antiderivative. Okay, so that's why we will need to use one of the transformation formula that we've seen, I guess last month. I gave you a couple of formulas. And here is a reminder. Okay, we have all these formulas that we've seen, I guess last month. You guys have to keep them in mind because I told you later on when we're going to do the techniques of integration, we'll see some complex integral involving trig functions, and we'll need, some of these formulas in order to simplify our integral. Okay, so now for our problem, I'm going to use number 3. I'm going to use number 3 here. I'm going to use formula number 3. Okay, so keep it in mind, cosine square theta is equal to 1 plus cosine 2 theta. No matter what is theta, theta is just an angle. In my example, I don't have cosine square theta. What I have is cosine square of 2 theta, but 2 theta is also an angle. It means I can apply this formula where I replace theta by 2 theta. Doing so, the left-hand side going to be cosine square 2 theta, and here's going to be 2 times 2 theta. That's why we'll get 4 theta here. You apply the same formula, but you subtract your theta by 2 theta. Okay? So that's exactly what I did to get the third step here. So from the second step, I just substitute here using that formula number 3, and I replace my theta by 2 theta. So I'll get here 1 plus cosine 4 theta over 2. And now we're ready to calculate the antiderivative. So the first term is 1. When you integrate it, you get theta. So the second term is cosine of 4 theta. When you integrate it, it's going to be 1 by 4 sine 4 theta. And you calculate it at pi by 4 and at negative pi by 4. So at pi by 4, you guys will get the first bracket here. At negative pi by 4, you'll get the second bracket. Just keep in mind here we have minus pi over 4 here. And when you substitute 4, so the second term here inside the first bracket becomes sine of pi. Same for the second bracket. When you simplify by 4, so the second term becomes sine of negative pi. And you guys know sine of pi is equal to 0. Same for sine of negative pi. Both of them are equal to 0. And after calculation, you guys will get pi by 8 because this bracket going to be pi by 2. And you multiply by 1 over 4, going to be pi by 8. Unit square. Any question? All right, I'll let you write down, the solution. If you guys have any question, let me know.
Sir,
Yeah.
how does the half become 1 over 4 in the third step
Here?
or fourth step? Fourth step. Yeah. The next
Here?
one.
Here?
Yeah. The half outside the bracket, how does it become 1 over 4?
In front here?
Yeah.
I took these 2 out. The denominator.
Oh, okay, okay. Right.
It's going to be 1 over 4.
Okay. Yeah.
And then the first bracket here is obtained when you substitute theta by pi by 4. It's going to be just pi by 4 and plus 1 over 4 sine of 4 times pi by 4. So this 2 is already out.
So, sir, the integration of cosine 4 theta is gonna be 1 divided by 4 sine theta, right?
Yeah, sine 4 theta. Yeah. Pardon? The denominator? No, I just took it out here. I took these two out. So be careful when you have a denominator, you cannot say you're going to integrate. It's going to be just 1/2. So I just want to show you here. So when you have, let's say, theta over 2 to integrate, you cannot say you're going to integrate the denominator, okay? Because this is just equal to 1/2 out of it's going to be 1/2 times integral of theta. And this is just equal to 1/2. But integral of theta going to be theta square over 2 plus the constant c. Okay? That is exactly what you use over there. We just took the 2 out, and you don't have to differentiate because this is a product. When you have a product, you integrate your function without the product. So if you remember, we've seen the property saying integral of k times f of x dx. If you look at the properties of the definite and indefinite integral, we've seen, the same property here. K is a constant, the integral going to be just k times integral of f. So in our example, k equal to 1/2. Is it okay? Sounds good? And you guys are done with this example, 13? Okay. All right, so next example here, we just want to get the area of the region, bounded by these two curves. The first curve is a circle, and its equation is 3 sine theta. And the second one is a cardioid. So we already seen a cardioid, how to sketch it. So we have the cardioid here. And again, here alpha is unknown, same for beta. So we don't know exactly the interval of integration. We don't know alpha. And beta is also unknown. So again, here we need first to find these two values before applying the formula, because here we calculate the area between two curves. And area between two curves, two polar curves is given by this formula. We're going to use this formula here, as I mentioned before. Okay? So it means you have to integrate from theta 1 to theta 2. So here we don't know the value of theta 1 and the value of theta 2. We need first to find them, and then we can apply the formula. So I said alpha, but it's supposed to be theta 1 here. Theta 1 and theta 2. We need first to find them in order to be able to find the interval. And as I told you, 2 weeks ago, anytime you guys don't know the interval of integration, it means you have some intersection point between your curves, and you have to find them. Your intersection point gonna be gonna give you the range for your integral. Okay, so that's what we're gonna do here. Instead of intersection point now, in this case, we're gonna find the values of theta corresponding to the intersection point between the two curves. And that's exactly what we did. All right. So we start by solving here, equating the two equations in order to find the values of theta corresponding to the intersection point between the two curves. And it's going to be 3 sine theta equal to 1 plus sine of theta. So it means 2 sine theta equal to 1. How to get this step? I just move, the sine theta from right to left. It becomes 3 sine theta minus sine theta. So that's why we got here 2 sine theta, and the right hand side now becomes 1. And dividing by 2, I'll get sine theta equal to 1 by 2. And now you guys can use the trigonometric table in order to find the angle between 0 and pi and 2 pi, for which the angle, the sine is equal to 1 by 2. And the angle should be in radians. Be careful, not in degrees. So we only have two values, two angles for which the sine equal to 1 by 2. The first one is pi over 6. And the second one is 5 pi over 6 in the second quadrant. Pi over 6 in the first quadrant, and 5 pi over 6 in the second quadrant. In the third and fourth quadrant, the sign is always negative. And here's our sign is positive. That's why we don't have to look at there. So now we're going to integrate from the smallest value, which is pi by 6, to 5 pi by 6. Now we know theta 1 is pi by 6 and theta 2 is 5 pi by 6. We're ready to apply the formula. But before doing so, we have one small problem to solve, which is to find the greater function between these two functions. Because the formula says it's going to be integral from theta 1 to theta 2 of 1 by 2, big bracket, the square of the greater function minus the square of the smallest function. Since the graph is not given, as I told you before, the way to find the greater function is to pick any number in the range of theta, and you substitute in the two equations. The greater function going to returns you the greater value. And is the value between pi by 6 and 5 pi by 6 is pi by 2. And you substitute here by pi by 2. So be careful. I'm not saying you have always to try pi by 2. The reason is pi by 2 is in the range. You can pick something else, but I just pick here pi by 2. Going to be easier for us. But you substitute here sine theta by pi by 2. Sine of pi by 2 is equal to 1. You multiply by 3. So you get the first function here returns you 3. In the second function, you substitute theta by pi by 2, sorry. The sign going to be 1 plus 1, you get 2. So it means the first function returns us, 3, while the second function gave us 2. So the greater function going to be, in this case, 3, the circle 3 sine of theta. So that's why 3 sine theta going to be the first term inside the bracket based on the formula. So we'll get here integral from pi by 6 to 5 pi by 6, 1 by 2. This is the greater function, you square it, minus the smallest function. So next we're going to expand these two brackets before calculating the integral. Any question before I move to the next page?
Sorry, sir. Could you please explain again how you got 5 pi by 6?
It's obtained from the trigonometric table. As I said, you need to know the trigonometric table. You find which angle has its sine equal to 1 over 2. We only have two angles, pi over 6 and 5 pi over 6, which is in the second quadrant, pi over 6 in the first one. I'm just going to draw the trig circle. If you have the trigonometric circle here, pi by 6 is this angle, and 5 by 6 is going to be here. And both of them have the sine equal to 1 over 2.
All right, thank you.
Well,
Sir.
yeah.
Like, how do you know, like, 1 plus sine theta is smaller than free sine of theta.
Okay, I said you pick any number in the range between pi by 6 and 5 pi by 6, and you plug them in the two equations. The
Like
greater,
random.
yeah, I just picked pi by 2, but you can take another number if you want. But the reason why I took pi by 2 is just the calculation going to be easier because I know sine of pi by 2 is just 1. Okay, if you want, you can take pi by 3. It's in the range, or 2 pi by 3. It's up to you. Sine of pi by 3, for example, is equal to root 2. Going to be root 3 over 2. You can use it. So we did something like that, like 3 weeks ago. I told you, you have 2 ways to find the greater function. The first way is just to get the graph, and the greater function going to be on the top. So here the graph is not given, and don't waste time sketching, polar graph, polar curve. So that's why I just want to pick a number. The second method is just to pick a number in the range and you plug it in the two equations. So the greater function gonna returns you the greater values. So that's exactly what I did here. I just took pi by 2 and plug it in the two equations. The first one gonna give us 3, and the second one gonna give us 2. That's why I know this is gonna be the greater function. Is it okay?
Yeah.
All right. All right, so next here, I'm going to expand this. Going to be 9 sine squared theta, the first bracket. And the second bracket, I'm going to expand it by using a plus b squared. So I'll get here 1 plus 2 sine theta plus sine squared. So next step, I'm gonna drop these inner brackets. So these inner brackets, when you drop it, you will get here 9 sine squared minus sine squared. That's why we will get 8 sine squared. And these two terms becomes minus 1 minus 2 sine theta. Is it okay? All right. So as I mentioned, you get here 9 sine squared minus sine squared. That's why we'll get 8 sine squared. And we have minus 2 sine minus 1. And we cannot integrate the first term because of the exponent. And here I'm going to use one of the forms that I gave you before in order to, simplify my integral. So back to, oops. So here I'm going to use number 4 because I have sine square, and because of the square, I don't know the antiderivative. If the square wasn't there, the anti going to be easier. So I'm gonna, I'm gonna use this formula: sine squared theta equal to 1 minus cosine 2 theta over 2. Okay, I'm gonna use number 4. And you guys can use it here. You can see I use sine squared theta is equal to 1 minus cosine 2 theta over 2. And at the front, you already have 8. I'm going to simplify by 2. 8 by here will get 4. So in front of this function, I have 4. That's exactly what I copy here. And the 1 here, the antiderivative is going to be theta. So for cosine 2 theta, so I'll get minus 1 by 2 sine 2 theta for the antiderivative. And the antiderivative of negative 2 sine theta are going to be plus 2 cosine theta, because the derivative of cosine is minus sine. And for negative 1, I'll get theta. So now we're ready to calculate, to use exactly what the FTC says, because this is an antiderivative. I'm gonna calculate, to get the first bracket here, I just substitute here theta by 5 pi over 6. And if you substitute here theta by 5 pi over 6, you multiply by 4, it becomes 20 pi over 6. Okay? And here I'll get 4 times half, going to be 2. And sine of 2 times 5 pi over 6, going to be 10 pi over 6. You can simplify by 2, it becomes 5 pi over 3. 10 pi over 6. For the second last term here, I'm going to substitute theta by 5 pi by 6 to get, 2 times cosine of 5 pi over 6. And the last term, I'm going to substitute theta by 5 pi over 6 minus the second bracket. So second bracket is obtained when you substitute theta by pi over 6 now, as the FTC says. So you replace here this theta by pi over 6, and then you multiply it by 4. That's why we got here 4 pi over 6. And here I'm going to substitute here theta by pi over 6. I'll get 2 pi over 6. And you simplify by 2, it becomes pi over 3. Second last term, you substitute here by pi over 6, I get this term. And here you substitute by pi over 6, they'll get minus pi over 6. And now we're ready to do the calculations. So you guys can notice here, if I take 20 pi over 6 minus 5 pi over 6 here inside from the first bracket, you calculate the first term minus the last one. You guys will get here 15 pi over 6. And you subtract again 4 pi over 6. So we get 11 pi over 6 because we got here 15 minus 4. Going to be 11 pi over 6. But 11 pi over 6 plus pi over 6, because you have 2 negative sign here, it becomes a plus pi over 6, and we'll get 12 pi over 6. That's why 12 pi over 6 is just equal to 2 pi. Now here, I'm going to calculate sine of 5 pi over 3 is going to be equal to negative root 3 over 2. Cosine of 5 pi over 6 is going to be negative root 3 over 2. And for this term, sine of pi over 3 is equal to root 3 over 2. Cosine of pi over 6 is equal to root 3 over 2. And you guys notice, these two terms cancel out, and these two terms also cancel out. So the bracket becomes only 2 pi. You multiply by half, it becomes pi. And pi going to be, in this case, the area of the region bounded by the two curves. Any question? Is there any question? So you all good?
Yes, sir.
All right, so this example, conclude this chapter. And next week we're gonna start, the second last chapter, dealing with, the techniques of integration. All right, so that's all for today. Before letting you go, I'm gonna just take the attendance. All right, so Magabet, are you still here? All right, thank you. Fatima?
Yes, sir.
Thank you. Alamin?